Hi there, and welcome to Mr. Morgan's Math Help for Algebra 1. We're looking at the unit called Sequences, which is connected to the Open Up resources. So make sure you're using the right video for the right homework. Today's lesson is called Growing Dots. And as always, make sure you've done the homework first or given it a good first effort, and then continue to watch the video to check your work to see if you're understanding it fully. That's what this is here for. This is here to help you see if you're getting it, so you don't get to class tomorrow and have to say, oh, I did it all wrong, I had no idea. This is here to help you to make sure you're on the right track, or if you miss class or don't have access to a tutor or people to help you, that's why we're here. All right, so let's take a look at today's homework. First homework question says, use the given values in the table to determine a pattern and then complete the pattern. All right, so we want to look at what's happening from basically moving from one number to the next number. What is the pattern going from one number to the next number? Well, at first, when you look at 3 to 6, you might say something like, well, it's adding 3. Well, it could be, but is that what happens here? What is 6 plus 3? Well, 6 plus 3 is adding 6. So that's not adding 3, is it? So we know it's not adding 3 or adding 6 because that's a difference there. So we're going to get rid of those. It has to be the same thing to be able to be a pattern there. So we know it's not adding 3. So what is happening? Well, how do you get from 3 to 6? I can multiply by 2. 3 times 2 is 6. What if I multiply 6 times 2? 6 times 2 is 12. That works. And 12 times 2 is 24. And it continues. So that pattern does work. So our pattern here is multiplying by 2. And so now we want to fill in the rest of the values in the table. So 24 times 2 is 48. 48 times 2 is 96. 96 times 2 is 192. And 192 times 2 is 384. Okay, so that's working there, no problem. Okay, we look at the next one here. Going from 76 to 60, well, I'm definitely going down. Looks like I'm decreasing by about 16. Yeah, 16 to get there. Is that same thing happening here? Well, what is 60 minus 16? That becomes a 5. 10 minus 6 is 4, and 44 matches there. So yeah, we're just subtracting by 16, and that's what's happening in that one. It's just subtraction. So let's take a look here. So 28 minus 16, well, I could do 28 minus 16, and that's going to be 12. All right, that's not too bad now. But then what happens? Oh no, I have 12 minus 16. And this is where some of you maybe got a little stuck because you're not used to working with positive and negative numbers. Okay, so let's think about it this way. Back in the day, we used to do it like this. You had 12 minus 16. And we would say, well, when we're dealing with numbers like this, let's think about it as adding the opposite. All right, and now because my signs are different, I'm going to find the difference. The difference is 16 minus 12, which is 4. And then I'm going to keep the sign of the value that had the greatest absolute value. So we're going to make it a negative 4. All right. The next one we're going to do, let's erase stuff here so I have some space to work. The next one we can do negative 4 minus 16. Again, we add the opposite. So now when the signs are the same, we find the sum. 16 plus 4 equals 20. When the signs are the same, we find the sum and we keep the sign. We keep the sign the same. So negative 20. And the next one, negative 20 plus negative 16 or minus 16. Find the sum, keep the sign the same. So negative 36. All right, so you do have to be able to work with positive and negative numbers there. So if you get a little stuck, that's what's happening. If you're using your calculator to do it, make sure you're understanding why it works the way it does, okay? That's really the key thing there, and sometimes we forget about that. All right, next one. We're going from 320 to 160, 160 to 80, 80 to 40. Well, the 80 to 40, I can look at that pretty quickly and say that looks like it's dividing by 2. Let's look over here. I know 16 divided by 2 is 8, so this also looks like dividing by 2. So it looks like my pattern is created by dividing things in half. Okay, so what's half of 40? 20. Half of 20 is 10. Half of 10 is 5. And half of 5 is actually going to be 2.5. Okay, or if you wrote 2.5, you could do that too. They both work. And our last one, number 4, going from negative 15 to negative 8. Well, that's actually an increase. We're going up, right? You got to think about a number line. We're going up a number line, and we're actually adding 7. Okay, so it's negative 15 plus 7. Well, the signs are different, so I find the difference. 15 minus 7 is 8, and I keep the one with the greater absolute value. Keep the sign for that one, negative 8. Okay, look at the next one, double check. Negative 8 plus 7. The signs are different, so I find the difference, and then I keep the one with the greater sign of the greater absolute value, negative 1. Matches that. Then we have negative 1 plus 7. The signs are different, so I find the difference, and I keep the one with the greater absolute value, which is positive, positive 6. Now at this point, it's just 6 plus 7, which is 13. 13 plus 7, which is 20. 20 plus 7 is 27. And 27 plus 7, which is 34. So it got a lot nicer at this point on, didn't it? All right, so that's what's happening with all of those ones there. So we got the table filled out, and we also included what our pattern or what's making the pattern there happen. All right. Number 2, lesson 2, growing dots. So some equations have 2 variables. You may recall seeing an equation written in slope-intercept form, y equals 5x plus 2. When given an x value, the equation can be used to determine the associated y value. So when it's basically saying, if we give you x, you can find y. Okay? A solution to an equation is the value that makes the equation a true statement. Therefore, a solution to an equation with 2 variables must include both the x value and the y value. Often, the answer is written as an ordered pair. The x value is always first. The example is xy. So that's our ordered pair. It means we're looking for that xy kind of value. So in this next part, we want to determine the y value of each ordered pair based upon the given x value, which means we're going to take the x value provided here, and we're going to put that into the equation to then figure out what's going to be the value of y. Okay, so let's do a few of these here together. So the first one, 6. So we would say 7 times 6 minus 13, taking the 6 there. That becomes 42, right, minus 13. And then 42 minus 13 is 29. Okay, and then we do the next one, right? 7 times negative 3 minus 13. A positive times a negative is a negative. Negative 21 minus 13. We add the opposite. Signs are the same, so we're going to find the sum and keep the sign the same. So we have negative 34. And our last one here, we'll do 7 times 1 minus 13 is 7 minus 13. Add the opposite. The signs are different, so I find the difference. 13 minus 7 is 6, and I keep the bigger sign, negative 6 there. All right, so that's the idea. We're taking the x value and we're plugging that in to see what the y value is going to be. I'm going to do one more of these here. I'm going to go ahead and do number 8 for you. Okay, I'm going to skip 6 and 7. It's, again, just plugging things in. You're high school, so I'm not going to give you all the solutions all the time, okay? So the number 8's a good one to look at because we have to pay attention to that negative x. All right, so let's put the negative 4 in. That means I'm going to have a negative, keep the negative sign, negative 4 plus 4. Okay? When I subtract a negative number, what I'm really doing is I am adding it. So I can really have a positive 4 plus 4, which equals 8. For the next one with the 1, I have a negative there. I put the 1 in parentheses because that's my 1 value. Oops. That happens every once in a while. It's like I touched something. Sorry. And then we add 4. So now the signs are different. So I find the difference. 4 minus 1 is 3. And the greater absolute value is a positive. So just a positive 3 there. And then finally, our last one, we have minus, and we put 7 here, plus 4. Signs are going to be different. So I find the difference, 7 minus 4, which becomes 3. And the greater absolute value in this case is the negative 1. So I have a negative 3. So these are great problems for two reasons. One, you're learning how to work with the equation and plugging in a variable, an x or a y, whatever it might be. But you're also having to work with integers. So integers are key here. I do have a whole video on integers. It was like a review thing for people coming into high school. So if you need to look at that, you can look that one up. I think it's underneath my university high school slides. So yeah, whole video on how to work with integers. Let's look at the next one. This is more about the lesson itself. So in the pictures below, each square represents one tile. We have step 1, step 2, step 3, and I want you to draw steps 4 and 5. So there's a pattern happening here. When I look at the first one, I see I have a square, and when I get to step 2, I keep that middle square, and now I'm adding one more around the edge. When I look at the next one, I have that one there, and now I'm adding 2 more around the edge. So that's what I'm seeing first of all. So what I'm going to do for step 4 is I'm going to draw my square, and because this one was adding 2 and that one was adding 1, I noticed that because it's step 3 and it becomes 2, it's like my step value minus 1 is what seems to go on around it, right? So if my step here is 4, I would say, well, it's going to be 4 minus 1, which is 3. I should expect to see 3 squares around it. I'll make a different color here, just the way I'm seeing it. So there's 3, 3, 3. Does that work? Yeah. So that's step number 4. Let's look at step number 5. I make my square. And step 5 is going to be the step minus 1. So in this case, here's 5 minus 1 is 4. So I will make out to here. And there's 4. And 4. All right, so that's what I have for step 4 and step 5. Now, here's what gets interesting. Dan explained that the middle tower is always the same number as the step number. So what Dan is saying is that the middle tower here is always the same as the step number. 1, 2, 3, 4, 5. That's true. 1, 2, 3, 4. That's true. 1, 2, 3, 1, 2, and 1. Okay, true. He also pointed out that the 2 arms on each side of the tower contain 1 less block than the step number. Let's see, is that an accurate statement? Let's take a look. What he's saying is that this becomes the tower number. So this becomes the step number. And this becomes 1, 2, 3, 4, the step minus 1. Create an equation that fits Dan's way of seeing the relationship. Okay, well, this is s minus 1, this is s minus 1, and that part is s. So what we would say is that for Dan, you would take the steps, which is this part here, and you're going to add to it then 2 of the arms, s minus 1. Okay, so that seems to work for Dan's method pretty good, right? You take the middle part here, the middle tower, and then you add the 2 arms. So that's one way of looking at it, definitely a way of seeing it, okay? And that's what's interesting. Like, I didn't draw it that way, right? I drew the middle, and then I just drew all of these as the ones that go with it. I did it as s minus 1, and really I had 1 plus s minus 1, right? Something along those lines. So anyways, and well, yeah. So for me, what I was doing, I guess, drawing, if I think about this here now a little more, I was doing 1, right? And then I was saying, well, if my step is 4, if my step was 4, then I said, okay, then I'm going to do 3. Which meant for my equation for how I was drawing them is I had the step, which was, not the step, I had 1. Sorry about that. No, don't erase the whole thing. I had this part here was step minus 1. This was step minus 1. This was step minus 1. And then I had 1. So I was actually doing 3 times step minus 1 plus the center square. Okay, that's what I was doing. That's different than Dan's, but that's how I was working mine out. Do they work the same? Looks like they might be. Let's see what's next. It says, Sarah counted the number of tiles at each step and made a table from what we just did. She explained that the number of tiles in each figure was always 3 times the step number minus 2. So she's saying it's always 3 times the step number minus 2. So she took these ones here, went, oh, there's 1 there, there's 4 there, there's 2, 4, 6, 7 there, right? And she 9, 10 there, and then we have 12, 13 there. And we see your numbers, 1, 4, 7, 10, 13. So she was just counting them up, putting them in her table. And she says that it's always 3 times, writing an equation, she says it's 3 times the step number minus 2. So 3 times the step number minus 2. And that's what she's saying. 3 times the step number minus 2. And so if that's true, let's take a look at this one here. You have 3 times 2 minus 2. That's 6 minus 2, which is 4. That works, right? You could check another one. There's 5. So 3 times 5 minus 2 is 15 minus 2, which is 13. Yep, that works. Okay, so good job, Sarah. Another way of looking at it. Nancy focused on the number of blocks in the base compared to the number of blocks above the base. So she looked at something like this. She said, okay, well, here's 1. Like that's step 2, right? That was step 2. So she said, let's look at the number of blocks on the bottom of the base. There's 3 right there, and the number on top is 1. Okay, so that's what she saw there. She said the number of base blocks were the odd numbers starting at 1. Let's take a look. Is that true? Well, 1, 1, 2, 3, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, so she's right. That's true. So we always have that. There's 1, and then there was 3, and then 5, and 7, and 9. Okay. She also noticed the number of tiles above the base followed the pattern 0, 1, 2, 3, 4. So she organized her work this way. First there are none on top, and then 1, and 2, and 3, and 4. Okay. Write an equation that fits Nancy's way of seeing the relationship. So writing an equation for her is going to be a little different. We have this part dealing with the base, and this part dealing with the top. Okay, so for the base part, we want to put it in relationship to the size, to the step number. Okay, so the base part looks like it's going to be the size no matter what. But it's the size. This one's a little strange. So for her, we would say it's. I want to get to the 1, right? If I said the base is the size, that doesn't always work because really I have 1 there, but when I get to 3, that's not the size because of the step was 2. So it seems to be that it's 1 more than that, right? Like, is it size? Is the step plus 1? If it's step plus 1, it doesn't work for that one because that becomes 2, and I want it to be just 1. So this one's a strange one to look at least to me. Maybe you're seeing it real quickly, okay? But I want to get 2 groups is the idea, and this isn't helping me here. So let's see what else we could do. My goal is to get a group that when I work it out, I have a 1 and then I have a 0. Okay, now I want to use the s in a group over here. I want to add it to an s in a group over here. Well, to get to the 0, that's pretty good. If I know the step, if I'm going to look at the 1, if I know step is 1, I'll do s minus 1 because I know if the step is 1, I get 1. That works out pretty well. What if I'm looking at, just real quickly, let's say I'm looking at 3 and 1. 3 plus 1. Let's see if that's going to work there as well. Well, if I did s minus 1 here, and the step for this one was the 2, 2 minus 1 is 1. Okay, so it's matching. So this part, s minus 1 on the end, does fit that one. So that's working there. The question is, how do I get the 3? Well, to get a 1 in front for this one, or to get a 3 in front for this one with an s value, that's going to be a little more complicated. What we want to do is, if I multiply the step by 2, now I have 2 times 1, which is 2. I want to get to 1 and subtract 1. Now I'm at 1. Does that work for this one? I want to get to 3. So 2 times the step number. 2 times the step number. The step number here is 2. So 2 times 2 is 4, right? That's what step number is 4. And if I subtract 1, do I get to 3? I do. So this part is really odd. So that's going to be the equation for what Nancy sees. You would say it's going to be 2s minus 1 for the first set of numbers plus s minus 1. Does it work? It absolutely works. Is that the normal way of seeing it? It's how Nancy saw it, and that's what makes it interesting, because what we're seeing here is that I saw it one way, which may or may not be right. Dan saw it a different way. Sarah saw it a different way. And then Nancy saw it a different way. So as you look at your solution you come up with today, maybe it's different from what I have here. And if you're thinking you did it wrong, maybe you didn't. Maybe it's okay. Check the values and see, does it work? That's what you want to see. If it works, then you did it right. Great job. Okay, next one. Based on the function notation provided, evaluate the function to determine the output. Example, instead of using x and y in an equation like y equals 5x plus 1, mathematicians often write the function of n equals 5 times n plus 1 because it can give more information. With this notation, the direction to find f of 2 means to replace the value of n with 2 and perform the operation to find f of n. Okay, and that's key. So what it means, if we're going to find the function of 2, we replace the value of n with 2 and then work it out. So we're plugging a value in to do that. The point n comma f of n is in the same location on the graph as x comma y, where n describes the location along the x-axis and f of n is the height of the graph. So essentially what we're saying is x comma y gives you the same info as n comma f of n. Okay, so we're kind of just switching from our coordinate points to functions, and we're saying they're essentially the same type of thing, just written differently. Okay, so we have two values here, two functions. F of n equals 8n minus 3, and g of n equals 3n minus 10. They want us to evaluate that for what's given. So let's look at f of 1. That means we're going to come back to our first equation, 8n minus 3. And we're going to plug a 1 into there. So we have 8 times 1 minus 3, which is 8 minus 3, which is 5. Okay, so that's great there. If we were to write this as a point of some sort, we would say that's our x value, 1, and our y value is 5. Didn't ask you to do that, but if you were, that's what you would do. For g of 0, we use this equation, so 3n minus 10, and that becomes 3 times 0 minus 10. 3 times 0 is 0. And 0 minus 10 is a minus 10. So as a point, we would call that 0, comma, negative 10. Okay, I'm going to let you do those two on your own because you're just going to plug them in and see what you come up with. Be careful of this one because it is a negative. So you're going to have to work by putting a negative up there and then adding two negative numbers together. All right. Write each expression as an exponent. Okay, this is a little bit of a review from back in junior high school days. So let's write these as an exponent. So in this case here, the number of these that you have becomes your base, right? The base number is what's down the bottom. And how many you have, 1, 2, 3, 4, becomes the exponential value 4. In this case here, we have 1, 2, 3, 4, 5, 6 of those. So we keep the base, and our exponent becomes 6. Here we have 1, 2. So our base is 1/5, and it's squared. All right, that's how our exponents are going to work. All right, write each expression in expanded form, then calculate the value. Okay, so expanded form, 7 to the first power. That's our base, and it's going to be there whole one time because there's only one of them. And so the value is simply 7. That wasn't too bad. And for 5 to the fourth power, this is going to be 5 times 5 times 5 times 5. We have 5 of them. The 5 is our base, and we have it 4 times multiplied. And you multiply that out, we should come up with 625. Expanded form for 22 is I'm going to have the 7 by itself, and then this chunk is what's actually going to be cubed. That's the only part. So it's 2 times 2 times 2. All right, so 7 times 2 is 14, times 2 is 28, times 2 is 56. All right, now we're going to evaluate for the expression, which means take the value they give and plug it into there. So 2 to the x power becomes 2 to the 9th power, which is 2, 3, 4, 5, 6, 7, 8, 9. All that. 1, 2, 3, 4, 5, 6, 7, 8, 9. Lovely. And 2 to the 9th power is something that you always have on the tip of your tongue. Not really. 512. And number 24. I'm going to plug that in right there. Remember, this becomes 6 times n, which is 3, and 3 squared. We need to do this part first. 3 squared is 9, so 6 times 9, and 6 times 9 is 54. Same thing over here for s. Plug it in there first of all. So we have 4 times 5 cubed. That becomes 4 times 5 times 5 times 5 if you rewrite that. And that is something, again, just a wonderful number here. This becomes, well, 5 times 5 is 25, times 125 is, 5 times 5 is 25, times 5 is 125. So you have 4 times 25 times 5. Let's do it this way. 4 times 25 is 100 times 5, which equals 500. And that's about it. So hopefully that helped you out again today. It's getting a little better each day as I go through these. It's been a while. So again, always do your homework first. Come back and check it. Here to help anytime. Hope you have a great day, and we'll see you next time.